Uh, the title of my talk is the impact of different GHRSST datasets on the simulation of Indian summer monsoon. This is a collaborative work carried out with the help of my colleague Dr. Randhir Singh, who did all the simulations. He is an atmospheric scientist and a modeler. And we both work in the Atmospheric and Ocean Sciences group in the Space Application Center. Now, coming on to the outline of this work, basically we know that the sea surface temperature is a very important boundary forcing to all the numerical weather prediction models. And the numerical, the Indian summer monsoon rainfall is very much, affected by the global variations in the sea surface temperature. For example, it is quite well known that during El Niño, the Indian summer monsoon gets affected. So the global variations in temperature do affect the Indian summer monsoon. And as far as the weather forecasting models are concerned, they make use of either the forecasted SST or a persistence SST for real-time applications. However, to analyze a hindcast event or a special event, it is important to prescribe most accurate sea surface temperature as a boundary forcing. Now, satellites, they give a very reliable estimate of sea surface temperature. However, at high resolutions, there are data gaps due to cloud, and at low resolution from microwave, you miss fine scale features. GHRSST data products actually provide, objectively analyzed data sets of sea surface temperature that combine the satellite and in situ measurements, and we get continuous data in space and time, which are useful for such kind of applications in the numerical weather prediction models. So, however, these GHRSST data sets, there are several agencies that generate different products, the GHRSST products, like the Canadian Meteorological Center or the DMI. So there are different products available. Now, for a user, it is very difficult to identify which product he has to use for forcing the numerical model, and so that he can get an accurate simulation of rainfall. So the objective of this study is basically to analyze the impact of different GHRSST products on Indian summer monsoon, and then try to identify which GHRSST product simulates the ISM rainfall with highest scale. Now, this is a very preliminary results which I'll be presenting. The study is still ongoing, this is the experimental setup that we have, made use of to, achieve these objectives. So we have made use of this MPAS model. Basically, this is a model for prediction across scales, and the configuration that we have made is high resolution for the Indian region, that is around 10 kilometer, and it has a variable resolution that we have made coarser outside the Indian Ocean region. So that goes up to 60 kilometer, and the model has 41 vertical levels, and it has all the state-of-the-art, physical parameterization schemes for convection, boundary layer, or the radiation. So this is the experimental setup, and the data sets that we have used to carry out these experiments are basically, the model has been initialized using the NCEP GFS initial conditions for the 25th June 2020. And then we have made use of the SST from the Canadian Meteorological Center, the GHRSST product at 10 kilometer resolution, JPL, that is 1 kilometer resolution, DMI, that is 5 kilometer resolution, UK Met Office, that is at 5 kilometer resolution, and the remote sensing systems product, that is at 9 kilometer resolution. So these are all the experiments that we've carried out, and along with that, we have our control experiment that we have forced with the GFS sea surface temperature, that is at 25 kilometer by 25 kilometer resolution. So these experiments have been carried out for the period June to September 2020, and the simulated rainfall has been compared with the India Met Department gridded rainfall product that is available at 25 kilometer by 25 kilometer resolution. So as I mentioned, the six experiments were performed, and the analysis that we are showing in this presentation is from 1st July to 30th September. So coming on to the results. Now, first I show here the differences between the GFS SST analysis and the different GHRSST products. And these differences are these are the mean differences for that our analysis period, and these are done on the model grid that at which we provide the SST as a boundary forcing. So basically, the differences are quite significant. As you can see, they range from from 0.5 to plus minus 0.5 degree K, and you have differences that are varying for different products. Like for example, for the Canadian Meteorological Center, we have the differences over the Indian Ocean, which are around 0.5 to 0.8 K, while there are less differences over the Indian Ocean in the remote sensing system product, whereas the same product has large scale differences over the Pacific, especially near the coast of west coast of South America. And so means what I mean to say is that there are regional variations of differences across different GHRSST products that is seen. So now coming on to the impact on the simulated rain, what we see on the left hand side set of 6 images is the root means per error of the simulated rain with the India Meteorological Department rainfall. So as you can see, the patterns of the errors are similar in all the 6 simulations or the experiments. The maximum error that we can see is along the Western Ghats and the in the central Indian and the northeastern Indian region. However, there are differences in different experiments. You can see that the errors are large if you look at the JPL results, where you see large errors near the in the Andhra Pradesh and the Orissa region, and in the REM product, you have large errors in the central Indian region. Now, when we compare these results, experimental results, with the control experiments, we see again similar sort of patterns, and the regional distribution of RMSC, it differs in different experiments. So definitely sea surface temperature, using different sea surface temperature makes an impact on these simulated rainfall. Now you can see that what we found, that the Canadian Meteorological Center simulated rainfall has the maximum correlation, while the GFS simulated rainfall has the least correlation. Then we also computed the matrices, the bias score and the skill score. What we found is that the bias score is closer to 1, that is considered to be the best for the GFS simulated rainfall. But when we see the skill score, then we find that the skill for the GFS experiments is the least for different rain rates. However, and then you have the, as you can see, the blue bar, that is the Canadian Meteorological Center SST, you have the highest skill. So, and then we also find out, we also see the differences in the moisture and the circulation. There are large differences across different experiments, and that is what we can make out from these experiments. However, these are quite, as I mentioned, these are quite preliminary results, and we did it with only one set of initial conditions. In fact, we have to take an ensembles of experiments to arrive at some robust results. So that is our future plan that we are going to do. So to summarize, we have analyzed the impact of different GHRSST products on simulating the Indian summer monsoon for the year 2000. And then what we see is that the regional deviations from observed rain are similar for all experiments. However, we find that the skill score for simulating rain is highest in the Canadian Meteorological Center product, and it is lowest in the GFS. So one positive aspect what we can see is that the satellite derived product, gives you the highest skill in the hindcast experiments. And we also observed the differences in the moisture and atmospheric circulations, and we need to carry out some detailed analysis. Thank you so much.
Thank